Isabella,
Axel,
and Katrina. Today we will be informing you about Newton's 3 laws of motion.
Newton's first law of motion,
also known as the law of inertia.
Newton's first law of motion states that an object at rest tends to stay at rest and an object in motion tends to stay in motion unless acted upon by an unbalanced force. You set up the first demonstration of Newton's first law by putting one cup down and a paper on top of the cup. You continue this pattern as many times as you wish. When the cups are not being acted upon by an unbalanced force, they stay still. When you pull paper from under the cups, they are being acted upon by an unbalanced force. Then the cup on top falls on the cup under it because the paper is no longer there. You set the second demonstration of Newton's first law of motion by starting with a cup full of water. Then you put a pie tin on top of the cup. After that, you put a toilet paper roll on top of the pie tin. Sitting inside the toilet paper roll is an egg. There is not an unbalanced force acting on anything, so it is static. When you hit the pie tin from under the toilet paper roll and the pie tin are both in motion, while the egg is still static. Since the egg is now being acted upon by an unbalanced force, the egg falls into the cup of water.
Newton's second law of motion.
Newton's second law of motion states that force equals mass times acceleration. Or in other words, acceleration depends on an object's mass and the amount of net force acting on the object. You set up the first demonstration of Newton's second law of motion by gathering different types of materials with significant weight. When you are pushing on a shopping cart, you are exerting a force on the shopping cart. When you are exerting a force on the shopping cart, the acceleration depends on the mass inside the shopping cart, resulting in a net force. This represents Newton's second law because the definition of Newton's second law is the force of an object is equal to its mass times its acceleration. The force is pushing the cart, the mass is the objects inside the cart. The acceleration is the result of the force you are exerting. You set up the second demonstration of Newton's second law of motion by setting up dominoes in a line with equal space between them. Then grab two balls with different masses. When you are throwing the objects at the dominoes, you are exerting force on the objects towards the dominoes. The more mass the object has, the better chance it has to knock down the dominoes. This relates to Newton's second law because the force you are exerting depends on the mass the projectile has when you get the acceleration.
Newton's third law of motion. Newton's third law of motion states for every action there is an equal and opposite reaction. This means, according to Newton's laws, if one object exerts a force on the second object, it will exert an equal force in the opposite direction on the first object. You set up the first demonstration of Newton's third law of motion by blowing up a balloon as much as you want. Then let go of the balloon without the neck of the balloon being tied. The action force is the air pushing out of the balloons. You can't see the action force, but you can hear the air coming out of the balloon. The reaction force is the balloon pushing on the air. You can see the reaction force as the balloons are being propelled. This represents Newton's third law of motion because it states for every action there is an equal and opposite reaction. The action force is the air pushing out of the balloon, while the reaction force is the balloon pushing on the air. These forces are considered action and reaction pairs. The second demonstration of Newton's third law is dropping a ball. The action force is the ball hitting the floor. The reaction force is the floor pushing the ball back up. You can see the reaction force when the ball bounces back up. This represents Newton's third law because the definition of Newton's third law is for every action there is an equal and opposite reaction. The action force is the ball hitting the floor, and the reaction force is the floor pushing back on the ball, making the ball bounce back up. On our second time. Okay. This ball.
Nice.
This is not going to work. Unless acted upon by an unbalanced force.
Newton's third law of motion states for every action there is an equal and opposite reaction. This means, according to Newton's laws, if one object exerts a force on a second object, I messed up. Okay. Wait.
3, 2, 1. Is that everything?
Yeah.
Okay. The dominoes.
Oh, wait. Now we messed up.
It's fine. We don't need to do all this. We could just show us what this. It could just stay. Okay.
Okay.
So I'll do the first one.
Are you seriously doing that as well?